So now we will see how to set up a case for combustion simulation. So go to setup and start your Fluent. Okay, so this is our Fluent interface. So for general, we will use pressure based steady state solver and our velocity is absolute. So go to model, go to energy and turn on the energy equation. Go to viscous modeling and select K epsilon. We will use standard K epsilon model with standard wall function. Select OK. Now go to species. Select the species transport option and we will use volumetric reaction with diffusion energy source, and in the mixture material we will use methane-air. So select this methane-air, and for turbulence chemistry interaction we will use eddy dissipation model. So remember this configuration for methane-air combustion. So we will use species transport with volumetric reaction, and the reaction will be diffusion energy source, and the mixing material will be methane-air, and the turbulence chemistry interaction will be eddy dissipation model. So select OK, and here in the material section you can see these materials already has been created for your combustion. So material mixture, go to create or edit. You can see the material type is mixture and the Fluent mixture material is methane-air. Here in the property section you can see the mixture species. Go to edit, you can see the species. These are the species that will react. So methane, oxygen, carbon dioxide, water and nitrogen. This is the global species for the reaction. If you go to reaction, our reaction modeling is eddy dissipation. If you go to edit, then you have the options for eddy dissipation. We have for stoichiometry, we have 1 mole methane that will react with 2 mole oxygen, and the product side we have 1 mole carbon dioxide and 2 mole water. So if you see the problem definition, we have also the same equation. So we will fix this. So now this is automatically fixed. You can change this, you can add species, you can subtract species, whatever you want. If you want number of product, you can increase number of product, you can decrease number of product. If you know the elementary reaction for your combustion, methane-air combustion is the most easy fundamental combustion. So we will use only 2 reactants and 2 product species. So select OK, and here you have all of these properties and options. In the mechanism option you have the volumetric reaction type. In the density option you have the density for the mixture, thermal conductivity, viscosity, mass diffusivity. You have all of these options that you can change if you know all of these parameters for different combustion. So close it. Now cell zone condition, our cell zone is fluid type and its phase is a mixture phase right now. In the boundary condition, this is the most important section. So we have air inlet, fuel inlet, interior, outlet and solid wall. So this white section is our wall, as you know. So go to air inlet, this is velocity inlet. So go to edit. In the momentum option we have to give the velocity of air. In the problem definition we have air velocity 0.5 meter per second at 300 degree Kelvin. So go to velocity magnitude and put the value 0.5 meter per second, and in the turbulent option select the intensity and hydraulic diameter, change the intensity from 5% to 10%, and the hydraulic diameter is 0.450 meter. In the thermal option, we have the inlet air temperature 300 degree Kelvin. Now go to species. Here you will change in the oxygen section 0.23, because for air we have 23% oxygen and 77% nitrogen. So right now we have to give the amount of oxygen presence in the air. Now select OK. Go to fuel inlet. This is also velocity inlet. Go to edit. According to our definition, the methane inlet velocity is 80 meter per second with 300 degree Kelvin temperature. So go here and in the velocity magnitude option write 80, and in the turbulent option select intensity and hydraulic diameter, change it from 5% to 10%, and the hydraulic diameter is 0.01, that is 10 millimeter. In the thermal option we have 300 Kelvin, and in the species we have to change here in the methane, because this is our fuel inlet, so methane is flowing from this fuel inlet, so we will select this and OK. In the outlet section, right now we have pressure outlet, so change it from pressure outlet to outflow, and this is set. We don't have any dynamic mesh. The reference value you can select and you can see what are the reference values are. In the solution method we will use coupled. So coupled is a special type of solution scheme by which we can model combustion, and here we will select the pseudo transient option. It will help us to converge the solution easily. If you really want to know what is pseudo transient option is, go to ANSYS Fluent website and you can get a lot of information from there. So solution control, here we have the relaxation factors. For our simulation we will change the density relaxation factor from 1 to 0.25. So this relaxation factor is sort of fixed for each and every simulation, but if you really want to change this, try to play with this when you have a very fluctuating solution or very irregular solution type, then you can change it, otherwise you don't need to change these values. So go to solution initialization, hybrid initialization, initialize, and it will initialize. So the initialization has been done. So go to run calculation. Our time step method is automatic. Change the time scale factor from 1 to 5. Number of iteration, let's do it 100 times and calculate. So our simulation has been done. Now we will see the results. So in the next tutorial we will see the different results and different outcomes of the combustion simulation.